So let's go to 12ths as my common denominator. This is 25 twelfths minus 50 twelfths minus 84 twelfths. And what in the world is that? That's negative 109 twelfths. All right. Minus 109 twelfths. I think it is. Yeah, it looks good. Negative 109 twelfths. It's going to be minus 8, is it? 8 and 1/12? Let me think. 8. Minus 9 and 1/12. All right. It's going to be very close to minus 9, isn't it? On the graph, it's virtually negative 9. So I'm going to write the vertex up here is negative 5/6 and negative 9 and 1/12. Okay. Now, I promised you a little calculator way of calculating the vertex here and getting an exact fraction answer. All right, so on my calculator, I have a store button, STO. So if I take my input of negative 5/6, negative 5 divided by 6, and I store it as x, then and I don't have the camera so I can set so I can focus on the screen of my calculator. Sorry about that, so I'm going to have to verbalize this. But if I plug in negative 5/6 and store it as x, then the calculator thinks x is negative 5/6. And so all I have to do, and this works on graphing calculators very well, is punch in 3x squared plus 5x minus 7, and I get negative 9.0833333333. All right. If you don't have a graphing calculator, if you have a scientific calculator, then it's going to take just a little more work to do that, what I just did, but to calculate this. All right. Now, my common denominator is going to be half of this denominator. Actually, I'm sorry, twice as much as that denominator, 12. So if I take my decimal number, negative 9.083333, if I multiply it by twice the denominator, times 12, I get negative 109. So it's negative 109 over 12. All right, so anyway, there are ways to do fractions on a calculator and get fraction answers, which is kind of nice. And so I just thought I would throw that out for you there to think about. Okay, well, let's do some erasing and make room for the graph. And let's see, remember that we have y-intercept at negative 7, and I'm going to keep that up there. So now it's going to dip down to around negative 9, so I'm going to need to write my graph that way. Now, I think I've told you this before, but maybe just in case, when you give me a graph, don't make it like this. All right, way too small. Can you read that? Probably not. I can't. Okay, and this is about the size I get on some papers, and maybe it's because no one's ever asked you to draw a good quality graph before. I don't know. But if you want full credit from me, you're going to need to give me a nice sized graph. Make it about 4 inches by 4 inches, at least. Use more if you want. Use a lot of graph paper. Paper is cheap. And if you need graph paper, go to my website. You can print some off for free. It's on my website. Not the class website, my main faculty website. Just look on the front page, the home page, and you'll find graph paper in there somewhere. So give me a decent size graphs. I'm looking for quality. And don't give me little stuff like this, because I have old eyes, I have trifocals, and I don't read well, and so you're going to have to make it nice and big for me, all right? So let's see. Probably about like this, would you say? So I'm going to go down to about negative 9. 3, 4, 5, 6, 7, 8, 9. And kind of over here, put some scale numbers on this. Okay, that's kind of an indication there. Now the vertex is at negative 5/6, which is close to negative 1, and negative 9 and 1/12, which is just a hair past negative 9 on the low side. So I come down, it's about there. Alright, and I'm going to label it negative 5/6, negative 9 and 1/12. If you want to make it negative 109 over 12, that's okay. Alright, so let's see. Now, here we go. What do I do from here? If I graph from the vertex, if I go right by 1 unit, I have to do what? I have to go up by 3. 3 times 1 squared is 3. So again, I'm focusing on this part of the function in order to generate my new points. This part here is what gave us the horizontal and vertical shifts down to here. But this part will tell us the proportional relationships. Literally, y varies according to the square of x. You remember the variation chapter. Y varies according to x, the square of x, or varies directly to the square of x, and my k is 3. My factor is 3. So if I go right 1, I go up by 3 squared. I mean 3 times 1 squared, which is 3. So 1, 2, 3, about here, okay. And then if I go left by 1 unit, I go up by the same amount due to symmetry. So take advantage of your symmetry here. If I go right 2 units, 2 squared is 4 times 3 is 12. So I go up by 12. So go right 2, up 12, puts me up to about there. And same over here, I would come over and plot it there. Alright, finally we have our y-intercept, which is at negative 7. So I've got 1, 2, 3, 4, 5, 6 points here. Alright, and try to make it curved. I know this one is almost a V graph, and that's because it's thin. It's been stretched by a factor of 3. But if you have a wider parabola, try to make it look like a parabola. Don't go like this. Okay, that's just plain laziness. Try to make a good faith effort to make a curve. And this one's a little hard to get a good curve on, again, because it's been stretched so much by a factor of 3. Alright, so there you go. Now, there are other ways to graph parabolas. You can just plug numbers in and plot them out. And it might be a good way to sort of check yourself. But I like to teach this so that we take advantage of symmetry, and we take advantage of the proportional relationships, variational relationships. We take advantage of the finding the vertex and the y-intercept and stuff like that. So I just think it's another way of graphing these that's kind of nice, and it doesn't take that long to get the hang of it. I realize the ones with the fractions are maybe a little bit of a nuisance, but on a graph you just estimate where the fraction is. Where's 5/6? Well, it's very close to 1. Where's minus 9 and 1/12? Well, it's just below negative 9, isn't it? And so you can estimate that stuff without much trouble on a decent sized graph and produce a good graph. So, all right, well, now we're going to move on and do some applications of quadratic functions. So now we get into the word problems.